Hello folks, don't know if you noticed, but ain't not too many wolves around there lately. Oh well, I guess it's still cold though. Okay, this morning, this afternoon, or this evening, whenever you're looking at this, we'll be, I've been recycling again. Okay, what we're looking at is DC motors. DC motors, okay? DC, direct current. Okay, now this is upon the request of a few of the viewers there. I just thought I'd touch on it. I'll try to be light with this one so I won't be past the... just more or less to give an idea of what we're looking at when we're looking at these motors here. This is a drill, but there's a motor that drives the drill, and different motors that we see. I was teaching something. Anyway, okay, we'll start off. The most simplest of the DC motor is the motors that have permanent magnets and have a wound armature. It has commutator, and it runs with brushes that run on the commutator. I don't know. I don't know if this does. I'm not too much a good for drawing. This here, see, permanent magnets. I did that last night there. Oops. Is it showing up on here? Right there. See? Permanent magnet. Right there. The commutator and the brushes are down here. I hope it makes sense. This is your simplest motor, cheapest motor in the DC category, and you'll find that in small things like little race cars that go around on the tracks. They're small motors. I don't know, not too much even on in the appliances there. That's another kind of motor, but we're going to cover that eventually. Now, there's three types of motors, of DC motors. Three different types. There's the shunt motor. I'm just reading out I made this last night there, so forgive me if I'm reading at the same time. The series motor and the compound, but that's a whole different animal, that compound one. We're going to talk about the shunt motor first. The shunt motor, which is this one here. See, it runs the hang on, I gotta make sure I say this right. It runs the brushes, and it runs the brushes that run the commutator, and it runs the field winding. Okay, field winding is wound, which means it's wire wound. They're in parallel, like positive goes to positive on the and on the field winding too. So they're in parallel. The attributes of this motor is that it winds up fast, but it has no, as soon as you load it, it goes down in RPM. It doesn't stay, but it gives you a great RPM. Okay, this is the, what they call the shunt motor. Now, we're getting into the series motor. The series motor is exactly what it says. It's in series. The field winding and the brushes going to the commutator are all in series, one after the other. So, this motor here has characteristics of not ramping up as high in RPMs as the shunt motor, but it'll give you more stable. Like you put it under load, it'll stay and give you stability. Okay. Now your these here motors, okay, they're shunt motor mostly.
Not shunt motor, series
And,
motor, dummy.
They're brushes. They used to be. I just want to touch a little bit. These motors here. See, you look on that. Yeah, you look all around it. And you remember in the days when they used to have a thing here on the sides. It was like a screw affair, and you can change a brush. Well, now they don't put that. It's still a brush motor, but they don't put that there no more. Now, the Makita, I think DeWalt, and Milwaukee. There may be other companies too. Rigid, I think too. They offer now. They offer these electric drills. They offer them with a non-brush motor. It's what they do to get this to run. Believe it or not, is it's done electronically. Is that what the operation of the armature in here? They put it on the outer winding, and then they're moving these windings north to south, and it's revolving within the drill. The north to south is revolving in the drill. They do this electronically, and your stator is fixed, and it's cutting the lines of force. I don't want to get into EMF and CMF and lines of forces and all that, but it's just like there's different types of drills now. Oops, I should get it in that picture here. Different types of drill. They're more expensive. They're a brushless motor. Characteristics. I don't have one, okay, but I've read. Characteristics of these drills is they have this more or less the same amount of torque, okay? Could be just a tad difference, maybe 5% difference, but they say it's the same. But your battery, for the amount of work done, will last almost, and almost is maybe 45% more than this battery here. So you're getting a 50% gain more or less by not having no friction. Well, that's what they maybe it's a more efficient motor the way it's done, but my way of thinking, okay, and I've evolved this through time, is the more you have to make things work, the more fallible it is. So here you change the brushes. Now you'll be going to the repair shop to change this electronic, however they do it. Milwaukee has enough of the circuitry in the battery. And is it this one? No, it's another one there. It won't charge. I have to do special tricks to charge it. So they have enough of the problems they have now without. Well, that's my way of thinking. Okay, for the normal Joe at home there, I don't think we can take the time and charge the batteries, and it won't make. If a guy works with drills all day, maybe it's worthwhile to have this, because not having any friction or contact points like your brushes, better off you are. Like your commutator doesn't dirty up or carbonize or arc and spark, and that's where you're losing some of that power from the battery. Okay. I hope this, I don't know if I'm, okay, now we're going to get into the compound DC motor. Now these motors you'll find in, I don't want to go too much in depth with them, but you'll find in the tow motors, you know those little lift trucks there? That's what, it's a compound motor. You'll find that in those cars, those electric cars, the compound motor. It's got a series feels in the winding. It's got shunt feels, like one is in series, the other one's in parallel. Okay, if you follow that. And they have different feels. They have the laminations. No, I don't want to talk about that yet. So that's more or less the application of a compound motor that we see. There's other applications. I just wanted to touch on something, eh? And we're just going to talk lightly about is when I started in the electrical trade, I was working in pulp and paper mills, and all your big motors, okay, they're all DC motors. DC as in direct current. It's not a sine wave, it's direct. Flat wave. Okay? But at a high voltage, when it was flat wave, okay? And the reason for that, it was the only way in the time to control the speed of a motor. So any motor that they wanted to control the speed, so you'd have big motors, like you'd have a, I don't know, 200, 500 horsepower motor, and you'd have a controller, and it was either a step controller or a controller, and they had resistance in that. And I remember on a dam, they had a crane for pulling the logs on the dam, and it was an old, probably 150 years old, maybe more. The name of it was Victoria, that crane, okay, in the day, right here in Ottawa, on the Chaudière Dam. And they used to pull the logs, okay? The logs were right at the base of the rock, like right sitting on the rock, the bottom's ones, eh? And the water is flowing over that, and they are all jammed up in the dam, eh? In the ice, eh? And they drop some keys down there, and they turn them by hand, and then they just, like the motor had tremendous torque, no RPM, but the the just lift, eh? Well, that was replaced by AC motors, believe it or not, and the way they got to control it, but I don't want to get into this, I'm just talking about it. Those that follow this will know. It's variable frequency drives. I'm just going to say that. That's the way to control motors these days. They're an AC motor, 600 different voltages, it doesn't matter, but they're variable frequency drive. VFD, variable frequency drive, and there's another name they call that. I don't know if it's a generic name or they call that a soft start, where you can ramp the motor up gently, and they can control it's incredible what they can do with these drives. But I don't want to touch on that too much, because okay. Now to terminate this little spiel, I hope it's see, the problem is, like, for me, I understand all this, but I kind of lose track that most people don't understand as much as I do. But anyways, I'm just going to touch a little bit so you realize that there's some motors that are DC, like some I don't know where it is. Well, some skill saws, okay? There are brushes in there. Any motor that's 110 and has brushes in it is a DC motor. But these motors, they have the laminations inside, they have to really make a good job out of the lamination, because there's a lot of eddy currents. But it's created with ACA, and they get into the brushes if they with the electromotive forces and the counter electromotive forces. The brushes take an awful kicking, eh? So they have to really do a good job of controlling the magnetism that's spread out and kind of integrated into the windings and keep it within the windings, because motor, that's more or less how it works. It's the interacting forces of the inner field to the outer field, okay? And it's the interaction that makes, and the flux. Nah, you don't know that. But anyways, it's yeah. So all your skill saws, your I don't know, table saws. See, something that you can keep momentum, eh? Like a flywheel momentum. Anything that has capacitors on it, that's not a DC motor. It's all the motors that you see, you look inside, they need ventilation usually, and you look inside and there's arcing and sparking there. That's a brush type, and that's a DC motor, but driven by AC. Trust me. Okay, I think I said enough about this. I hope I didn't lose too many people on the way. I did some more drawings here, but I'm not gonna show you. I think I more or less covered it in general. Probably could have done more, or probably could have done it better. That's Gator's explanation of DC motors. There's a few guys in there that wanted to know. I don't know, these electrical showings there, if it's worthwhile or not. That's going to do something else on generators, but I'll think about it there. I want to do something on panels too, eh? I want to touch on that. And another thing too I want to touch on is the way people wire outlets. Something bugs me. That's all I see on the net, eh? And I'm just gonna. But anyways, that's for some other day. For now, I say salute you all. Comments are welcome. I try to give you non-generic answers, and yeah, I hear that, eh? You subscribe and try to give me airtime too, if you have the patience. If you don't have the patience, just let it run. Go to the washroom. Go make yourself a drink. Let it run, and when I'm done, well, then you come back and you switch to somebody else. Okay, friends. It's been it's been trying doing this way. Well, it's not been trying. It's been fun, but I hope I didn't lose you in this. I'm sure some people like Grampy and probably a few others, Marty and a few others in there can follow this, and the other people, well, I don't know. I just try to give a light touch, but maybe it's too much. Okay, salute you all. We'll see you in the next one.